And welcome to the CAP5 AS Biology Model Answers. Question 1. Explain why both the heart and arteries are described as organs. Well, it's just a straight definition. An organ is different types of tissues working together, and that's all you need to put. So, more than one tissue, and we don't need more than that. The table shows changes in the volume of blood in the left ventricle over a period of 1 second. Okay, and let's just remind ourselves where we are. So we got the heart there. Let's divide the heart in two. Let's have our veins in there. Let's have split the heart up into its chambers. Then we get the arteries coming out the top. Okay, we have got some valves. These are the AV valves, and we've got semilunar valves going up there. And so we've got, this is the left ventricle, right ventricle, left atrium, right atrium, and then we've got, this is the aorta, and these are the arteries. So that's where we are in the heart. So this is in the left ventricle, so we are just down there. Length of one cardiac cycle, and it says use the information in the table. So what we're looking here is for a repeating pattern, because this will go up and down and up, down, up, down every heartbeat. So we're looking for a repeating pattern here. So down here we've got 270s and 100, and then there's a 70 and 100. So probably what happens is the cutoff is kind of after there, and then it's back down to 0 again. So 270s and 100, 70, 70, 100, and then we're back to the start again. So we're going to have 0.8 for that. So it goes from there, and then this is kind of the last thing, and then it's back down to 0 again. So from 0 to 7, back down to 0, and that would make 0.8. 0.8 seconds. At what time is there least blood in the right ventricle? And to get the mark here, we need to explain our answer. And it says here right ventricle, but there's no data for the right ventricle, because this is for the left ventricle. So really what it's testing you is, do you know that the right ventricle would be exactly the same as the left ventricle? And so least blood in the left ventricle, well, there's 0, so that would be the right ventricle as well. So the answer is 0.4 seconds, and the reason is because the right would be the same as the left. So right, same as left. Between which times are the muscles in the wall of the left atrium contracting? Give the reason for your answer. So it's asking us when are these walls contracting? Well, when they are pushing blood into the left ventricle, and so the left ventricle is filling. So that's the key there. So when is the left ventricle filling? Getting higher on this chart. And so I would say this left ventricle contracts, blood starts to go into there, and then certainly just before the maximum of the left ventricle. So here we've got this kind of maximum in the left ventricle, so this left atrium must be filling, well, it must be contracting. So I'm going for 0 to 0.1. You could have any time later as well. You could have any time up in there as well. Time 0.1 seconds, because the volume of the ventricle is increasing, and so it must be filling. So the volume of the ventricle is increasing, so must be filling. So left atrium contracts, blood enters the left ventricle. Between what times are the semilunar valves in the arteries open? So here we are looking for our semilunar valves. Our semilunar valves are here, so this is our semilunar valves. And we are looking for when blood is coming out, because that will force them open. So in our diagram, let's just put our, so we're getting blood coming up here, and we're only going to get blood going up there when this left ventricle is contracting, and so the volume will be getting smaller. So we need to look on here, when is the volume of the left ventricle getting smaller? Well, you see 100, 70, 30, 0. So anytime here, I would suggest our volume is getting smaller, particularly down at this end where the semilunar valve would definitely be open, because we've got the maximum kind of force of blood through there. So I'm going to go for 0.3 to 0.4. But any time from kind of 0.1 upward to 0.4 would do. And that's because our volume of the left ventricle is decreasing, and so it must be emptying and going into the arteries, thus opening the semilunar valves. So ventricle volume decreasing, ventricle emptying into arteries, and that forces open the semilunar valve. Now we've got a calculation. The maximum volume of blood in the left ventricle is 45 cubic centimeters. Calculate the volume of blood at 0.5. So it's just can you convert this percentage? Can you do a percentage of this volume? So where are we on our table? 0.5. So this is where we are. This is the data that we're going to use, and that is 35%. So 35%, and that's going to be of our maximum 45 cm cubed. So our calculation is going to be 35 divided by 100 times by 45. My trusty calculator. 35 divided by 100 times by 45 is 15.75 cm cubed, and we could round that off to 15.8 or 16. Have a look to see whether it asks you to do that. Probably in this data we've kind of got one significant figure, two significant figures, so rounding off will be fine.